All right, 2.3, evaluating limits analytically. Example 1, find the limit of each using direct substitution. So there's a bunch of methods that we can use to analyze a limit and figure out the answer. The first section, we looked at it graphically. We looked at one-sided limits. We looked at the limit coming from the left versus coming from the right. Okay. Sometimes you can do direct substitution. Okay, direct substitution is very similar to solving an equation. Let's say you had f of x equals x squared. Okay, and I wanted you to solve when x equals 2. Okay, so to solve this, you would do f of 2 equals 2 cubed, which would be 8. Okay? This is similar to direct substitution for limits. This method doesn't always work, but when it does work, it's an effective strategy to use because it's pretty easy. So let's look at A. They want us to find the limit of 3 when x equals 2. So first of all, this line here is f of x equals 3. So this is the function f of x equals 3. Okay? We want to evaluate this limit when x is 2. So when x is 2, f of 2 would be 3. This is direct substitution. So the answer here is 3. Okay, so here we can do direct substitution. I'll show you some cases throughout today when direct substitution doesn't work. Let's look at B. Okay, let's look at this one. For this one, the limit of x as x approaches -4. We want to figure out what this limit is equal to. So we're going to start off, we're going to do this again. This line here is f of x equals x, and we're going to try direct substitution. So we're going to do f of -4. What would that equal? Well, I think we don't even need the graph for this one, but when x is -4, f of -4 is -4. So this would be equal to -4. Okay? Let's look at C. The limit of x squared when x approaches 2. So again, let's see. This is f of x equals x squared. Let's see if we can evaluate this limit using direct substitution. So we're going to plug in 2 for x. And we can here, we get 4. So when x is 2, this would be 4. Okay? Alright, so that's it for this first example.